Hey guys, so we are going to be taking notes 2.5 today, and another big long title: compare and order fractions, decimals, and percents. So now that we know how to convert fractions and percents to decimals, and decimals to fractions and percents to fractions and decimals, we now can get everything to be the same kind of number so that we can compare or order them. Okay, so got some vocab words, things we've talked about back in chapter, I think it was 4. First is least common denominator. Least common denominator. So the smallest denominator two or more values share. That is the same, okay? So least common multiple of the denominators of two or more fractions. Okay, so we talked about this when we needed to add or subtract fractions. We had to have common denominators. Okay, so we may need to do that. And the next thing we're going to talk about is to compare and order fractions. Now the funny thing is comparing and ordering kind of go hand in hand, because comparing means to look at, try to see what's the same, what's the difference, but order says, okay, well, let's kind of look at them and put them from the smallest to the largest, or the largest to the smallest, okay? So if I just have a set of fractions and I want to order them, these are the steps that I would follow. First, I need to find the least common denominator, and I'm going to abbreviate it, and I should put it back over here. In fact, I'll do that. We'll say LCD. So we're going to find the LCD of the fractions. The only way to compare fractions is if they all have the same denominator, and once they have the same denominator, then we'll just compare the new numerators, right? So to do that, that's called creating equivalent fractions. So, oops, why did I write in purple there? That's funny. Let's try that again. 2. We're going to write the equivalent fraction. Equivalent, equal value. For each original fraction using the LCD, least common denominator, as the denominator for all. Okay, so every fraction now is going to have the same denominator. And then, I kind of gave away the punchline on this one. You're just going to compare the numerators. Okay? So how do we compare? Well, it depends upon if we're just comparing two things, or if we have more than two things, are we going to order them? So let's remind ourselves what comparison symbols look like. Okay, you have greater than, and so what people always, probably, I've always heard this story that teachers tell you that the hungry alligator, arr, arr, arr. He's always trying to chomp down on the biggest thing he can find. So that open is always facing the bigger number because he wants the biggest bite possible, okay? Then we have going the other direction is less than, which kind of makes sense because the smallest part of the symbol, the point, is on the left when it's less than. Get it? Left, less. Okay. And then it's always possible that the two things you're comparing are equal to each other. Okay. All right, so what if you don't have just a whole bunch of fractions that you're comparing or not being asked to put into order? What if you have a mixture? Okay, so let's talk about that. Comparing fractions, decimals, and percents. I'm going to give you what I think is the best strategy to do this. Okay, now, some people will say, well, what do you have more of? Do you have more fractions? Then make them all fractions. Do you have more decimals? Make them all decimals. Do you have more percents? Make them all percents. What if you have one of each? So my suggestion is you're going to rewrite each value as a decimal, because really I think changing a fraction to a decimal and changing a percent to a decimal pretty easy. Okay, doesn't take a lot of steps, doesn't take a lot of work, so that's going to make it, I think, far faster to get things done. And then compare the same place value oh, I wrote value, that's so funny. Same place value where the numbers are different. So once you see a place value where the numbers aren't the same, that's when you can start doing your comparison. And again, you'll understand this as we go through our examples. Now, I will make one suggestion. That number lines, if you're good at graphing on a number line, number lines are useful to compare values. Now, if putting things in the right place on number lines is not your best skill, then that strategy may not work as well. But some people like that visual to help them. All right, so we're going to go to the next page and we're going to do a bunch of examples. So for the first, we're going to have the directions that say fill in each, and then there's going to be like an open circle with, and then we're going to put the inequality sign in there. Greater than, less than, or equal to make a true statement. Oops, that was terrible. Try that again, huh? There we go. So a true statement is what's in front, does whatever the inequality says with comparison to the back. So we'll do two of those. And let's see, we have two fractions that we're comparing. Okay, so one of the strategies is to look for LCD of 3 and 9. So let's see. Since 3 goes into 9, the smallest denominator would be 9. So that means I'm going to make both of these have 9 in the denominator. So 9, 9. So the first guy, I would need to multiply top and bottom by 3. And that would give me 6 ninths. Oh, let's put my little comparison circle in there. And then the other guy, oh, he didn't change at all. So the denominator, or the numerator stays at 4. So the only place that I'm going to do my comparison, the only place that I'm going to look is going to be in the numerator. And we want to know, how does 6 compare to 4? Well, 6 is greater than 4. So then we can go back and say, well then, that means 2/3 is greater than 4/9. So keep in mind that when I create my new fractions, I got to line them up underneath their original one, okay? All right, let's try another one. What if I have 5/12 and I want to compare it to 7/8? Okay, now the 8 doesn't go into 12, so I'm going to use the factor ladder. Remember we used that back in, I think, chapter 1, right? Let's see, they're both even, so I can pull out a 2. So 12 divided by 2 is 6. 8 divided by 2 is 4. They're still both even, so I can pull out a 2. 6 divided by 2 is 3. 4 divided by 2 is 2. All right, there's nothing more I can get. So remember what LCD is. I'm going to grab all the outside numbers. Looks like an L that's fallen down. Or no, it can look just like a regular L. So that says your LCD is going to be equal to all those outside numbers multiplied together. So it's going to be 4 times 3 is 12, and 12 times 2 is 24. So that's going to be the new common denominator. Okay, so we're going to have 24, 24. Okay, so the first guy, I'm going to multiply 12 by 2 to become 24, so I have to multiply 10 by 2. 5 by 2 is 10. I'm always giving away the answer. And then for 8, we have to multiply by 3 to get to 24. So I multiply 7 times 3 and we get 21. So where I look for my comparison is just my numerators, and 10 is less than 21. So I'm going to bring that answer back up to the original problem. So 5/12 is less than 7/8. Okay? All right. Let's do, I think I'm going to split this in half now. So order 1/2, 5/6, 2/3, and 3/5 from least to greatest. Oh, greatest. Try that again. There we go. So from least to greatest. Wow, there's a lot of information in just this one problem. So let's see. Okay, we're going to have to figure out LCD. Unfortunately, we've got, oops, I made a big mess here. We've got quite a few denominators we need to look at. So let's see what we got. We need to find the LCD of, and we have a 2, a 6, a 3, and a 5. Whew. Okay, so let's see how we're going to do this one. Let's just list them out. And remember what we said. I'm going to put them in order from least to greatest. I don't know why. I just organize things that way. So when we have 3 or more fractions with different denominators, instead of looking for something they all have in common, we're going to look for something that at least 2 of them have in common. So I noticed that 2 and 6 are even, so I'm going to pull out a 2. So 2 divided by 2 is 1. Now, since I can't divide 3 by 2, I just write 3 again. Since I can't divide 5 by 2 evenly, I just write the 5 again. And then 6 divided by 2 is 3. Again, I'm looking for something that at least 2 of them have in common. And I see a 3 that shows up 2 times. So I can't divide 3 out of 1, so I leave it 1. 3 divided by 3 is 1. 5 divided by 3 can't do, so I just bring the 5 down. And then 3 divided by 3 is 1. Now I know I don't have anything other than 1, so I grab all of these guys, and that's going to give me 2 times 3 times 1 times 5 times 1. So 2 times 3 is 6, times 1 is 6, times 1 is 6, times 5 is 30, times 1 is 30. So I'm going to take my fractions, and I'm going to rewrite the original ones. 1/2, 5/6, 2/3, 3/5. So I'm going to tackle this problem one piece at a time, and the big piece right now is common denominator. So I'm going to rewrite these fractions so that 30 is the common denominator. All their fraction bars, and then we start doing our math. Okay, so we've got 2 times 15 is 30, and 1 times 15 is 15. Then we've got 6 times 5 is 30, so 5 times 5 is 25. And then we've got 3 times 10 is 30, so 2 times 10 is 20. 5 times 6 is 30, and 3 times 6 is 18. So now where I'm going to look is simply at the numerators, okay? So I'm looking at my numbers here, and I'm going to put underneath the order that I think they should go in. So 15, 25, 20, 18. So I got 2 numbers in the teens, 15 and 18. And the directions say least, which is another word for smallest. So of the numbers, the smallest one is 15. So I'm going to put a little 1 there. The next smallest would be the other number in the teens. That would be the 18. Now I've got 25 and 20. So between those, 20 is smaller than 25. So he would be the third number. And then that makes 25 the last number, or as we say, the greatest. So he would be called the largest, right? Now, we're not going to write those numbers. We're going to go back to the original ones. So we would say, okay, so I'm going to write here, original fractions, to remind you. So the first one went with 15/30, which is actually 1/2. The second one was the 18/30, and that went with 3/5. The third one was the 20/30, that went with 2/3. And last but not least was the 25/30, which goes with the 5/6. And that would be your answer. Okay, oops, I forgot to put a problem number. That's number 3. So number 4, we're going to do actually a couple of problems under this one. So this is not number 4. Oops. There we go. We're going to say example. Directions are going to say fill, not find, fill in each, again, circle with, and then we're going to use our comparison symbols, greater than, less than, or equal to make a true sentence or statement. I like the word statement. Sounds more grown up. Okay, so our fourth example would be, what if I had a decimal 7/10 compared to a fraction 8/11? Okay, so what we said is, in this case, we're going to go ahead and divide. Okay, so we're going to take 8 and we're going to divide it by 11. So 11 can't go into 8, so I'm going to put in a decimal point, and then I'm going to annex a 0. And 11 can go into 87 times, which is 77. When I subtract, I get a difference of 3. But I got to go one more time, because right now they both have a tenths. There's 7 in the tenths column. 11 can go into 32 times, which is 22, and we get a difference of 8. So at this point, I'm going to stop, okay? So what we're comparing is 0.7, and we're going to give it a second digit of 0. And then we're going to compare, and I'm going to put it underneath so I can see the comparison. 0.7, but let's change his color. That's the second guy. We'll make him pink. 0.72. So now I'm going to look and see if I can find where they have a difference. So they both say 0 in the ones column. Tenths column both say 7. So here's where we find a difference. So this guy is going to be smaller, because 0 is smaller than 2. 0 is less than 2. So that makes the 0.7 less than the 8/11ths. All right, let's try another one. Let's put them here. So let's say we want to compare 1/5 to 0.2, or 2/10. Okay, so we're going to take 1/5 and we're going to change them to a decimal by dividing. So 1 divided by 5. So I put in a decimal point because it can't go in. Annex 0 and 5 goes into 10 twice. So now I have 0.2, and I'm going to compare it to 0.2. Guess what? They're the same. So this is the situation where you would say these are equal to each other. Okay. All right, let's do one more. Let's do it over here. And we get 42%. And we want to compare it to 44 hundredths. All right, so now what we have to do is change our fraction, or percent, to a decimal, So we're going to divide by 100, and that's going to give us 42 hundredths. So then I'm going to bring over the 44 hundredths, and then we're going to be looking for comparison. So ones column, they both say 0. Tenths column, they both say 4. Here's where we find a difference. So notice 2, he's less than 4. So that means 42% is less than 0.44 or 44 hundredths. All right, there you go, guys. We'll talk about this in class. Bye now.